Okay, the next topic in Module 6 is solving a quadratic equation using the square root property. So you're going to see problems that look like, for example, y plus 2 squared minus 44 equals 0. Okay, now do not expand that out. That's kind of the first thing that a lot of kids want to do is they want to expand that. You don't need to. So y plus 2 squared would equal positive 44, like that, okay? Which means y plus 2 could either be the positive square root of 44 or the negative square root of 44. Could be either one, okay? So we're going to simplify that square root of 44. So remember, the biggest perfect square that would go into it, so 4. So it's 2 square roots of 11. So y plus 2 would equal positive or negative 2 square roots of 11. Okay? And then we just get that 2 to the other side. And usually we put it in front of the square root sign so we can kind of express both solutions in one line like that. Okay? It could be negative 2 plus 2 root 11 or negative 2 minus 2 root 11. So Alex might have you put them both in separately, and if it does, there's your answers. Okay, we'll do another one. We have y plus 5 squared minus 8 equals 0. Okay, so we'll get the 8 to the other side. We'll square root everything. And you make sure that you do the positive and negative square root. Okay, because y plus 5 could be a negative number, and then when you square it, you get 8. Okay, or it could be positive. Your square root of 8, remember, can simplify because 4 goes into it, so 2 root 2. And then subtract your 5 and put it in the front of the expression. Okay, so y could equal negative 5 plus 2 root 2 or negative 5 minus 2 root 2. So you might be forced to write it this way. Any math teacher would also take this answer. Okay, all right. We will look at another one, completing the square, which you guys have seen before. Again, if you have that Algebra 2 interactive notebook, it's a good idea to hang on to it. Okay, so when you complete the square, just remember you have this pattern. I don't know why I was spelling pattern wrong. That a plus b squared is a squared plus 2ab plus b squared. Okay, so if you have an x or a variable in there, which you're going to have in these, it would be x squared plus 2vx plus b squared. Okay, so for example, if you had something like x plus 10 squared, you'd have x squared, and then all you'd have to do is 2 times x times 10, so plus 20x plus 100. Okay, and what you'll notice here is that this number is always 1/2 of this number squared. Okay, so what these are going to do is they're going to have you fill in the blank there. Okay, so they'll give you something like x squared plus 20x plus blank, and you fill in the blank. So all you need to do is take half of this to get 10, and then square 10 to get 100. Okay, so an example that they might give you, and they won't always use x. The example that came up on my screen is v squared plus 10v plus blank. Okay, so 1/2 of 10 is 5. 5 squared is 25, so we would fill in the blank with 25. Okay, we can do another one here. I don't know that they're going to have any negative. Let me see here. If any examples come up with negatives. Oh, they did. Okay. We have y squared minus 6y plus blank. Okay. Same thing. It doesn't change it if it's negative. We just take 1/2 of -6 to get -3. And then -3 squared is 9. Okay. So that number is always going to be positive. All right. We can move on to another one. What do I got the next one? Quadratic formula. A lot of nice little review ones in here for you guys. All right, we have applying the quadratic formula. Exact answers. So that's when you leave the square root in your expression. Okay. So first of all, remember your quadratic formula is when you have something in the form of ax squared plus bx plus c equals 0, then x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Okay, and these are just going to have ones where we have to simplify that radical. So we can do an example here. If we have something like 2x squared plus 7x minus 5 equals 0. So a is 2, b is 7, c is -5. Okay, so x would be the opposite of b, so -7, plus or minus the square root of b squared, which would be 49, minus 4 times a times c all over 2a, which would be 4. Okay, so be careful under that radical. We would have 49, and we have minus a negative. So we're going to have plus, and it's going to be 40 over 4. So -7 plus or minus the square root of 89 over 4. There are no perfect squares that go into 89. So we cannot simplify that radical at all. So it's -7 plus the square root of 89 over 4, or -7 minus the square root of 89 over 4. Okay, let's get another one here. Well, it looks like a lot of them aren't going to have radicals that you can simplify. That's good. Okay. Another example. 5x squared minus 9x plus 2 equals 0. A is 5, b is -9, c is 2. X is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So we're going to have 9 plus or minus the square root of 81 minus 40 all over 10. So 9 plus or minus the square root of 41 over 10. And we cannot simplify that radical 41. Okay, so 9 plus the square root of 41 over 10, 9 minus the square root of 41 over 10. Okay, moving on to the next one. We are going to do solving the quadratic equation when we have complex roots. Nope, I didn't do that. Okay. So this is when we're going to get to some imaginary numbers here. Okay, and again, it's another thing you saw it in Algebra 2. It's kind of towards the end of Algebra 2, I think, but we got it. So I'm going to have something like 4x squared plus 5x plus 2 equals 0. Okay, and again, complex roots means that there's going to be an I. So if you're doing this and you're getting an answer that doesn't have an I in it, you're doing something wrong. Okay, so go check your work. We're going to have, in this case, A would be 4, B would be 5, C would be 2. So again, quadratic formula, opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. So negative 5 plus or minus the square root of 25 minus 32. There's where your complex root comes from because we're trying to square root a negative there. Okay, and then just remember the square root of negative 7 is the square root of negative 1 times the square root of 7. So I square root 7. Okay. Some books might have you write that as 7 or square root of 7i too. Sometimes you put the I out front so that it doesn't get mixed in. It doesn't look like it's under the radical. Okay. So we've got, I'm going to go over here, negative 5 plus or minus the square root of 7, I'm going to make it really obvious that it's not under there, over 8. Okay, and we do have one more step to this. It's common to write complex solutions, remember, is that A plus BI. So we just split that numerator. So we'll have negative 5 over 8 plus or minus square root of 7 over 8i. Okay, or if you needed to write out both, x equals negative 5 over 8. Oops. Fix my Chromebook again. X equals negative 5 over 8 plus square root of 7 over 8i, or x equals negative 5 over 8 minus the square root of 7 over 8i. Okay, we'll do another one of those. So the next one we've got 3x squared plus x plus 4 equals 0. A is 3, B is 1, C is 4. So x will equal, again, the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. So negative 1 plus or minus the square root of 1 minus, that will be 48 over 6, which is negative 1 plus or minus the square root of negative 47 over 6. So negative 1 plus or minus the square root of 47 I over 6. And then we might split that up. Negative 1 over 6 plus the square root of 47 over 6i, or x equals negative 1 over 6 minus the square root of 47 over 6i. Okay. Let's see, I think we have, yeah, that's another topic. Next one we have is solving an absolute value equation. Another one from Algebra 2. This is called, they're calling this problem type 4. Okay, so remember, if I have, for example, the absolute value of x is 3, that means x could equal 3 or x could equal negative 3. Okay, so these are going to have two answers, and you have to make sure in this type of problem that you check your answer. Okay, because you may get, remember, what we called extraneous solutions. Okay, so an example on this one, 3 times the absolute value of w minus 5 plus 14 equals 44. So you kind of just treat those absolute values like parentheses. So 3 absolute value of w minus 5. The only thing is you don't distribute, okay? And even if they were parentheses, you wouldn't want to. Some kids tend to try to do that, and it works out in the end. It won't work out with absolute values, though, okay? So we're going to subtract that 14. So we have 30. And we're going to divide by 3. So the absolute value of w minus 5 equals 10. So that means w minus 5 could equal 10, or w minus 5 could equal negative 10, which means w could equal 15, or w could equal, if I add 5 to negative 10, I'll get negative 5. Okay, and then just check your answers. Okay, 3 times the absolute value of 15 minus 5 plus 14. 3 times the absolute value of 10 plus 14. 30 plus 14, that's 44. It checks. Okay, 3 times the absolute value of negative 5 minus 5 plus 14 would be 3 times the absolute value of negative 10 plus 14. 3 times 10 plus 14 also equals 44. Okay, let me get another one here. Okay. I don't think they're going to throw any at you that have no solution in this one. Okay, another example. Absolute value of 2y plus 4 minus 27 equals negative 15. Absolute value of 2y plus 4 equals, we're going to add 27 to both sides, so we'll get 12, which means 2y plus 4 could equal 12. So once you get down to only absolute value left on one side, that's where we take it away and say it could be positive 12 or negative 12. So that would mean 2y could equal 8, which would make y equal 4, or 2y could equal negative 16, which makes y negative 8. Okay, so those are your two answers. I'll leave it to you to plug them in, but they do both work. Okay. I think we're going to keep going here. You know what? Actually, that was 5 topics, wasn't it? Okay, so I'm going to stop there with that one.